Alright, welcome back, young JavaScript ninjas. Alright, so now that we've refreshed our JavaScript, you know a little bit about what Node.js is, I want to talk a little bit about asynchronous programming and event-driven programming because this is really the core of Node.js and the advantage and the benefit that it really offers to those that are using it, i.e. us. Alright, so let's talk about a couple analogies to give you a good or a better understanding about this concept. All right, so let's talk about the traditional model. All right, so in the traditional thread-based system, that's what we call it, thread-based. So remember that in an operating system, you can span multiple processes or threads, which means that an application running can run on its own thread in memory, and it has its own memory and computing processing power, etc., etc. So these are what threads are. So in the traditional thread-based system, all right, when you get to the receptionist, let's just say we're taking an analogy of a doctor's office. When you get to the receptionist, you stand at the counter for as long as it takes for you to complete the transaction. All right. If you fill out 3 forms, you would do so right there at the counter while the receptionist just sits there waiting for you. All right. This is what we call blocking because you're blocking her or him for servicing any other customers. All right. So in the traditional thread-based model, we call it blocking on input-output. Right? Nothing else can happen until the current process is done. Right? Well, what's wrong with this? Well, when we try to scale it, right? The only way to scale a system like this is to add more receptionists, right? And this is expensive. One, it's expensive because it costs more to pay more receptionists, and it's expensive because it takes more. It has to take more space for all these receptionists to work, right? So it's very hard to scale a thread-based system. And when we say scale, we mean how do we handle more requests, right? Remember, only one person at that counter filling out the forms at one time. So we say we want more people to be able to fill out their forms because you don't want to just have one person at a time because then the line in your doctor's office would be very long, and that's going to cause people to leave. So we want to avoid that, right? So we want to scale it up to handle more people. All right, so we can do that with an event-based system. So let's talk about that scenario. When you get to now, instead, when you get to this window and you find out you had to complete additional forms, the receptionist, instead of you filling them out right there, the receptionist is going to give you the forms. She's going to give you a clipboard and a pen and tell you to come back when you've completed those forms. Hey, get out of here, come back later, right? So you're going to go over there, sit down in the waiting room, and the receptionist is then going to help the next person in line. So you're not blocking her or him from servicing other people because you're going off to do what you still need to do while he or she helps someone else. This is what we call non-blocking I/O. All right, so when you're done with your forms, you're going to get back in line. You're going to wait to speak with the receptionist again, and if you have done something incorrectly, right? This is what that error stuff in the chapter comes out. If you've done something incorrectly or need to fill out another form, he or she is going to give you the new form or tell you the correction, and you'll do the process of going off, doing your work, and then waiting in line again. All right, so this enables the receptionist to handle more people efficiently. All right, so this is already highly scalable, as you can see, because now we're not blocking with just one person. The receptionist can handle multiple people, and everybody's still doing something, right? Exciting stuff. If the line gets too long, you can certainly add another receptionist, right, to handle more people, but you don't need to add them as fast as you do with the thread-based system. Let's look at it from another perspective. Let's talk about fast food, right? So we go to Mickey D's. I like Mickey D's. You like Mickey D's, right? So we go to Mickey D's. You get in the front of the line. You give your order to the cashier, right? And then you're going to wait right there until that cheeseburger is ready and giving it to you, all right? The cashier can't ask another person their order because you're right there in the way. You're blocking, right? So if we need to service more customers, guess what we got to do? We got to add more cashiers. So they come from the back, they were sweeping, they come up, they open another register to handle the next customer. All right? All right, let's talk about the event-driven way. So as soon as you place your order, it's sent off to someone else to fulfill while the cashier is still taking your payment. So they only have to have your payment before they start cooking your order. When you're done paying, you step aside because the cashier is already looking to service the next person. Hey, I need to get that order for those 6-piece chicken McNuggets in. right? So in some restaurants, they might even give you a pager that flashes and vibrates when your order is ready to pick up. The key here is that you are not blocking the receiving of new orders. New orders can still come in even though you're waiting. And when your food is ready, the cashier or someone else behind the counter is going to call out your name, AT, and the order number, or they're actually going to trigger my pager, and I'm going to go up to the counter and get my food. So we say that the event of the order being ready causes the person to perform some function or action. So we have some event that happens that triggers something else to occur. Event driven. Alright, so what's the relationship of all this to Node.js? Well, traditional web servers, i.e. IIS or Apache, are based on the thread-based model. Alright? That means that when you launch Apache or another web server, it starts to get connections from users. What is the connection? It's when you type in a URL and that server hosts that site that you're trying to go to. Alright? When it gets a connection, it's going to keep that connection open until it has performed a request for the page that the user is asking for, or whatever other transaction that the user is trying to do. All right. Sometimes it takes a few microseconds to get this page from the disk, or actually write some result to the database. All right. While all this is going on, your web server is blocking on that input-output operation. All right. That's what we call blocking I/O. In order to scale this type of web server, what do we have to do? That's right, we need to add more copies of the server. All right. Now, in contrast, Node uses that event-driven model that we talked about, where the web server is going to accept a request, then it's going to spin it off to be handled. Then it's going to go into the next web request while that other one is being worked on. All right. So when the original one is completed, it's going to get back. It gets back into what we call a processing queue. All right. And then when it gets to the front of the queue, those results are going to be sent back or whatever action is supposed to occur next. All right, this is what we call non-blocking I/O or event-driven I/O, because we're not waiting for any read or write operations. All right, so just to give you a concrete example of this process, you use your web browser to make a request for about.html on a web server built with Node.js. All right, the Node server is going to then accept your request, and it's going to call a function to retrieve that file from disk. Alright, so while that Node server that we created is waiting for the file to be retrieved, it's going to grab another request to start handling that one. Alright, and when the file that we originally asked for is retrieved, there's going to be what we call a callback function. If you remember that from core JavaScript, we're going to start using those callback functions now. That callback function is going to insert it in the queue, and this event loop keeps executing. That's going to continuously keep pulling these things off the queue and sending them back to the web browser. Alright, so hopefully that gives you a better understanding of the event-driven paradigm. If you have any questions, let me know. Take care. And I'm hungry now, so I'm going to get McDonald's. See you later.